In this video, I'll talk about the last periodic trend, and that is electronegativity. Electronegativity. So, same drill. Electronegativity is there with ionization energy and electron affinity as it increases from left to right and down to up. So increase. If you can read that would be awesome. So impressive. Increase. It's kind of better. So electronegativity is one of the most important concepts you'll ever use in chemistry. You'll pretty much use it in everything, organic chemistry or loose structures. Electronegativity is pretty important. So just En, and that is the ability of an element to, it has two abilities. The first one is attract electrons towards itself. So that's pretty much telling you it likes having electrons. Something that's very electronegative likes having electrons. And when bonded, this should also say attract electrons. So the ability of an element to attract electrons towards itself and when bonded to another atom. You should wrote here attract electrons and then just put the two options, but it's okay. So in other words, something that is very electronegative will be very will have a very high electron affinity. So large electron affinity and a high ionization energy. That means it will want to be like that. This is the equation for electron affinity. So it will, something that's very electronegative will want to have a large electron affinity. So it will probably want to be negative. And when you think of that again, let's go with the same examples. Chlorine most likely will want to be like that. And fluorine is the most electronegative element in the periodic table. So fluorine has you could say a big appetite for electrons. It never gets tired of getting electrons. So in most cases fluorine will be like this. It has a very good ability to pull electrons towards itself even when it's bonded. So I already said it. Fluorine is the most electronegative element of the whole periodic table, followed by oxygen and chlorine, and so on. So something as let's go with calcium this time. It won't have the ability fluorine has to pull electrons towards itself. It'll pretty much want to give those electrons it has to the fluorine, because metal, if you remember, will always like to be a cation. So it will lose electrons. It will want to lose those electrons and give them to the fluorine in this case. I mean, and you can just see that with salt. When you ionize salt, you have NaCl, this normal table salt. When you ionize it, we have Na plus Cl minus. So the sodium, which is at the left part of the periodic table, is the metal part, the part that has a very low electronegativity. is positive. So it gave those electrons to something that has a very high electronegativity, like chlorine. So you can see the negative there, meaning that it has a very high electron affinity, a very high ionization energy. So it's pretty hard to remove this electron and give it back to the sodium, and therefore the chlorine is considered very electronegative. Well, that's the definition of electronegativity: the ability to pull electrons toward yourself, and even having one bonded. Well, those are the periodic trends, and just to recap. So just to combine all trends, we'll take this. Actually, let's make it this, like this, like. Alright, let's stick with one side. So, red means electronegativity, En, electron affinity, and ionization energy. So, En, Ea, Ie. And blue means atomic radius, metallic character. So the metallic character and the atomic radius goes as it goes down, and to the left becomes bigger. So francium will be the element with that's considered most metallic and with the biggest atomic radius. And for the case of electron affinity, electronegativity, and ionization energy, fluorine will be that element. So right and up, electronegativity, electron affinity, and ionization energy. And well, those are the 5 different periodic trends. And if you found the video helpful, like it and share it with your friends.